Hello you all. Today we are going to present a simple example on how to do integrated cost estimation with HISES. First, you need to build a case. We are using the example INTPRO 02B from the second chapter. The first thing you must do is, once you have already run the system and you have results, you must go to the ribbon Economics, and on the left you have the three options for the default values. In cost options, you can specify the basis for calculating the economic evaluation according to the region. By default, it is specified for United States in imperial units, in English units. We are going to change this, Browse, Templates, select the European with metric units, and double-click on the file. In this form, you can also specify the starting date for basic engineering, the length of the plant startup, el tiempo que lleva la puesta en marcha, and also the operating life of plant, for example, in our case, 12 years. Also in process utilities, you can say the utilities you are going to use, steam, electricity, and so on. It is a blank list. However, if you do not specify any value, the ones used by default by Aspen will be used. Finally, in the form stream prices, you can give the price for the raw materials and also for the final products you are going to sell. Once you have completed these defaults, you must activate in the ribbon the economic analysis. Once you have activated the economic analysis, you must follow the 4 steps which are here represented in buttons. The first one is mapping. You receive the message that you must run the model again. The same results are obtained, of course. And now the mapping form will appear. Mapping corresponds the equivalence between the blocks you have used for simulation and the real equipments you want to be economically calculated. The first time you use mapping, you must use default mapping. It is done automatically by Aspen. In the following ones, you must use last mapping so that you do not have to repeat all the steps we are going to do now. Click on OK, and this is the default mapping. For example, for the unit E130 flash, we go to the main flowsheet so that you remember, is this one. Remember, this is a partial condenser. Stream 6 is cooled down to obtain a liquid fraction and a vapor fraction, a partial condenser. However, as this unit was simulated by a flash, the equipment which has been mapped by Aspen is vessel, a cylinder. We know this is a partial condenser, so we must change this. In equipment selection, choose heat exchangers. You have the option between heat exchanger, reboiler, and furnace. We select heat exchanger, and here you have the different types which are offered by Aspen. We are going to choose almost the last one, floating head shell and tube exchanger. Un cambiador de calor de tubos y cabezal flotante, de carcasa flotante. Okay? The second one is compressor. And for this case, a centrifugal compressor of the horizontal type has been selected. For us, it is okay. If you are using a different type of compressor, you should change it here, as we did before. For the mixer, the equipment type C is selected. This means that no cost is associated to this equipment because it is only a T-pipe. It's very cheap. Solo es una tubería en T. For the stoichiometric reactor, an agitated tank, enclosed and jacketed, is selected. We are going to accept this economic evaluation. And finally, for the last equipment, R110 flash, remember, this is not a real equipment. This is only to simulate the separation between the liquid and vapor phases in our system, but it takes place in the real reactor inside of the vessel. So this equipment must not be evaluated as it is not a real equipment. We select and delete. Accept. Now we have completed the mapping, and so every piece of unit is identified with the real equipment. After completing the mapping, you must size the equipment. Click on the Size button. This sizing is automatically performed by Aspen. The next step is to check the sizing which has been developed. Click on the View Equipment and you receive the result summary for equipment. At this time, no economic evaluation has still been performed, but if you click on the Equipment page, you see that different equipments have been sized and they are described in the next pages. The agitated reactor, this is the sizing of the equipment. You can change here, for example, the selection of materials of construction. For example, shell material is by default selected as carbon steel. If you prefer any other alloy, you must select it. The same for the heat exchanger. The mixer has no cost associated, and the centrifugal compressor. After sizing and checking the equipment, you perform the economic evaluation. Click on Evaluate, and once completed, click on the Summary page. You can check here the different costs associated to your plant. To identify the different economic terms, you can ask for help. Click on the F1 on your keyboard. This is the page associated with economic evaluation, the different steps that we have described before, and here you can find, for example, the meaning of installed cost and equipment cost. The equipment cost represents only the very equipment cost associated with the project component. This means the equipment with the basic cost from the supplier. However, the installed costs include other costs associated to the equipment for installation and operation, as they are the total direct material and labor costs associated with the project component. You can also check the cost of utilities, in this case electricity and cooling water, and the cost for the different unit operations, the reactor, the condenser, the mixer, and the compressor, and also a detailed description of all the equipment. Finally, you can click on the Investment Analysis button to receive a detailed cash flow analysis of the process. Once the process is finished, we received an Excel file with very detailed information of the economic evaluation of the process. For example, in the third page, cash flow, you received a lot of information about the cash flow analysis of the process, including the evaluation of the net present value and the internal rate of return. As we have not declared any price for the product streams, we are not selling any product, the internal rate of return cannot be calculated. However, the net present value is evaluated only from costs. That's the reason why this value is always negative. It is included for the 12 years for the life of the process, and at the end we receive the value. The higher is this negative net present value, the higher will be the cost of our project.